Hello! So we are nearly done with our tour of group theory. Today I want to present another kind of group, just to give more examples of what these algebraic systems can look like. And in the second part of today's lecture, I'll be talking about quotient groups. Now that sounds scary, but we've actually been working with them since the first day of class. Now, the group I would like to introduce today is one of the wallpaper groups. So again, thinking of groups as a way to categorize symmetries. We've seen in our tutorials how we can take a simple polygon or a shape and think of all the different symmetries that that object has. Those symmetries together form a group because we can always just follow one symmetry, right? Maybe a mirror reflection, by another symmetry. Maybe a reflection back would be its inverse element. So the wallpaper groups are looking at symmetries of the XY plane, the whole plane, going off infinitely horizontally and vertically. So what symmetries are allowed here? We can have translations, right? Just moving left, right, up, down, maybe diagonally, just a simple linear movement. We can have rotations, which I can't actually demonstrate with my mouse here. Or we can have reflections of the plane. So the plane itself, if you just had a blank canvas, is not terribly interesting. So what we're going to do is we're going to say there is some pattern on the xy plane that is repeated in two different dimensions, right? Maybe it's got some sort of repeating behavior in the x dimension, maybe some kind of repeating behavior in the y dimension. And it doesn't actually matter what that pattern is, just that it repeats itself. So I've chosen an image here, and I have tiled it across the plane. And any way I can take the plane and move it around so that my wallpaper still looks the same will be one of the symmetries belonging to this wallpaper group. So I can start with this album cover here, and I can move it over by one, and I can imagine the entire XY plane moving over to the right by one album cover, and then we won't have even noticed the difference because everything just lines up. Everything repeats that way. I could move over by two album covers, or by three, or by four, or I could even go to the left. So I have lots of different symmetries in my horizontal axis. I have the same kind of tiling behavior in the y-axis as well, the vertical axis. I can take the entire plane and move it up by one album cover, or I could move it down by one album cover, and those will also be symmetries. Or I could even move in some diagonal direction, right? I can take this album right here, and I could move it up over by 4 albums horizontally, 2 albums vertically. And if I move the entire plane that way, my repeating pattern will line up with itself. And after that move, it's as though nothing changed, right? So that would be another example of symmetries. So this group has infinitely many symmetries, right? For every single album cover I see, I can move this particular one over there, and those will all be different elements of this wallpaper group. Now, this is sort of the visual idea of what's going on. In terms of algebra, let's bear in mind that I can only move over by whole numbers of my boxes, my album covers in this case. So if I think about moving vertically by M album covers and moving horizontally by N album covers, then I can represent that as a vector. N and M are going to be the coordinates, and both of these are integers because I have to move by whole number amounts, positive for forwards, negative for backwards. So this group of symmetries of my wallpaper design is actually the group of integer vectors. I'll call this Z squared. There's other names for this group, particularly in the study of wallpaper groups. Ultimately, I will not be testing you on the categorization of wallpaper groups. Just this is another example of things we can work with. And it ends up being vectors, which should be a little bit familiar. Even if you haven't seen vectors in previous classes, I've used these a couple times in my group lectures now. So if I was going to add two of my vectors together, I just do it x coordinates plus x coordinate gets me new x coordinate, y coordinate plus y coordinate gets me my new y coordinate, and so on. Now, you might be thinking that the wallpaper that I just showed you, as radical as that artwork is not terribly exciting in terms of its symmetries, right? Everything is just, do I move left or right? Do I move up or down? And I can imagine a more elaborate wallpaper, maybe one that has some kind of reflective symmetry, like a mirror image line in that wallpaper. Or a wallpaper that has a rotational symmetry. So here is a different wallpaper that has different symmetry properties. Let me focus on this point right here, the corner of 4 of my album covers. And I can see that there is a rotation. If I just stuck a pole down in the XY plane here, and I rotated by 90 degrees, then, of course, this album cover will be here. This one will go down here. This one will go down over there. This will go up. So that looks good. And in fact, all of the rest of the album covers in the plane will also rotate. So this is my axis of rotation. This album cover up here will rotate to this position. This one will rotate down here. It's cut off by my name, and so on. So rotating around this point will give me a symmetry of this wallpaper, and it's not the only one. So of course you can see there's repeats of this same looking flower looking spot. So here is another axis where I could just stick a pole into my XY plane and rotate here. I can rotate by 90 degrees, or rotate by 180, or rotate by 270, or rotate by 360, and that will get me back to where I started if I rotate a full 360 degrees around this point. And there's a whole bunch of these rotation points you can see on the screen. So this wallpaper group is different from the last one. Well, the last one didn't have any rotations at all. One of the interesting things is that this rotation as an element of the group has a finite order, right? My translations have infinite order. No combination of translations will get me back to the identity. They just keep moving farther and farther away. But the rotations, at least the rotation here, if I do it 4 times, it's as though I didn't move the plane at all. So that'll have an order of 4. Now I claim there's another spot on this wallpaper that has a rotational symmetry. See if you can find it. I'll give you one of them. So if I look at this point here, I can rotate again, and my album covers will fill in the place of the next one, right? So I can take this cover here, I rotate it down so the text is upright. I can take this one here, I can rotate it over so the text is vertical again, and so on. So this point right where my mouse is another point where I have a rotational symmetry, and again, order 4. And you can see this again is sort of copied here. I've alluded to this, but I'll say it explicitly. This wallpaper also has translational symmetry, right? I could have taken this rotational point and just moved it over here. Since we were talking about subgroups yesterday, you can think of the previous wallpaper group I just looked at as a subgroup of this one, right? So I still have horizontal translation, or vertical translation, and so on. Those are still elements of this wallpaper group where the previous one did not have rotational symmetries. Now I claim there is a rotational symmetry of order 2, meaning that I have to rotate by 180 degrees to get my symmetry and not just 90 degrees, right? So this was a rotation of order 4. I have to go around 4 times here to get back to where I started. Here's another order 4. And if I look to this corner right here, I can take my 2 album covers that share this corner, and I can rotate by 180 degrees to get a symmetry. But if I rotate by only 90 degrees, that's not enough, right? If I take this album cover here, rotate by 90 degrees, the title text there will be on the wrong side. So I do have to go 180 degrees to get my symmetry at this point. So I also have a rotational symmetry of order 2. I have to go around by 180 degrees. So these are 2 different wallpaper patterns with 2 different symmetry groups. And I'll tell you for free that all of the wallpaper groups have been categorized. We know exactly what they are and how they behave. And there's 17 of them. So I've included a link here in my slides, or you can just pause the video and copy this into your browser. And I didn't make this. It is a Java app where you can take all the different symmetry group types. I'm going to put on a little grid here. Let me look at the group PG. So I can draw inside of this. Nothing terribly fancy. And I get a wallpaper pattern with the symmetry group of what I picked. Again, I haven't gone through the categorization of this, but it's a fun little thing to play around with the different kinds of symmetry that you can get for wallpaper groups. Okay, that's enough of that. I hope you enjoyed seeing a new kind of group. Can have fun drawing wallpapers, I suppose. The second half of this lecture, I'm going to talk about quotient groups. I'll see you in a bit.